CTFxC here, and today we are talking about Rocket. So on November 14th, we are going to an event in Huntsville, Alabama called Random Acts of Intelligence. So Random Acts of Intelligence is basically a giant meetup with Derek, Destin, CGP Grey, Minute Physics, and Numberphile. So that seems really fun. Destin actually said there will be no video of it, but he lied because I will be recording some of it. It's going to be at the NASA Air and Space Center, which ties in well with the rocket study we've been doing recently. So we've shot a couple more rockets within the past few days, and today we will be talking about how the physics of how the rocket works. We are mostly going to be talking about Newton's laws of motion and the four forces that act on a rocket: thrust, drag, lift, and gravity. So the first force we are going to be talking about is thrust. And thrust is probably the force you're going to be thinking about most when you think about rockets. Thrust is the force the engine makes when it pushes up. So in the engine, there's this solid fuel. When it gets a spark, it starts burning and turns into gas. And the gas starts coming out of this tiny hole, and it expands, and it tries to get out of the hole, and it just pushes way up, shooting the rocket into the air. This uses Newton's third law of motion. For every action, there is an equal and opposite reaction. The action is the gas pushing down, trying to escape. And the reaction is it pushing up and making the rocket go up. And that is thrust. You've probably seen this, like when you're blowing up a balloon and you let go of the balloon before tying it. It pushes itself out. The action is the air pushing out of the balloon, and the reaction is the balloon flying around all crazy. Like all forces, thrust is a vector, which means it both has a magnitude and a direction. So if you were to draw this vector on graph paper, you would use an arrow. The length of the arrow is how strong the force is, and the direction of the arrow is in what direction. So the direction of the rocket's arrow would be up because the rocket is going up. So I'm going to draw it here on my graph paper, a thrust arrow. So I drew my little rocket on here, and I am drawing a really long arrow to represent the thrust, because if the arrow wasn't very long, then the rocket wouldn't go up very high. So the second force we're going to be talking about is gravity. And most of you guys probably know what gravity is. It's the force that pulls everything towards the center of the Earth. And if we didn't have it, we would be probably in space and dead by now. So gravity is also a vector because it has a direction and a magnitude. The direction is towards the center of the Earth, and the magnitude is how strong it is. So I am going to be drawing my gravity vector smaller than the thrust vector, because if it was larger, then the rocket wouldn't lift off at all. Now we will be talking about the aerodynamic forces, starting with drag. So drag is pretty much what it sounds like. So if I take a book here, if I take a book here and I drag my hand across it, it will be moving in the same direction that my hand is moving. Just like the drag on the rocket is the air rubbing against the rocket, pulling it in the same direction the wind is going. But it's going to be a very, very, very small vector. It's not very large, and it does have some of an effect, but not the biggest effect. Not as big as the thrust or the gravity. Now we can add these three vectors together and see what direction the rocket is moving and how strong and how fast it is going. Vector addition is pretty easy. All you do is you kind of add the arrows together. So you start the tail of the arrow at the tip of the other. So I'm adding my gravity. I'm adding my gravity to my thrust right now. So my gravity is 3 blocks. So I will put 3 blocks down from the tip. I'll go 3 blocks down, and that's my gravity. And then I will add my thrust, which is only 1 block. So I will add my thrust at the tip of the arrow and down to there. So then you just get from the tail of the first vector to the tip of the last vector. So in this case, mine will be like that. So this is the net vector, which is all the vectors added together. So that's the direction the rocket's going in, and as you can see, it's going in the same direction as the thrust, because thrust is the vector in here. It's not as strong as the thrust, however, because it's being slowed down a little bit by gravity and drag. The last force we're going to be talking about is lift, which is a lot like drag. So when wind runs over something, it's not always going to be straight. So if it's slightly tilted, then the wind kind of bounces off, and it creates a force perpendicular and at a right angle. So if the wind bounces off the rocket and goes up, it will create a force that goes down. If it creates a force that bounces down, it will create a force that goes up. You may have experienced lift before if you stick your hand out of the window of your car and you redirect the wind up, then it's going to create a force that makes your hand go down. If you redirect the wind to go down, then it's going to create a force that makes your hand go up. So it's kind of strange because lift is still called lift, even though it's making the rocket go down. It's still called lift, which is a bit strange. The way the rocket uses lift is for stability, which sounds kind of odd, but I will tell you how that works. So if the rocket is going straight up and it kind of tilts, then the air is going to be redirected by the fins, and since it's being redirected the opposite way the rocket's turning, it's going to create a force that pushes it back up. So lift is going on the whole time the rocket is in the air. So it will start to wiggle that way, lift will redirect it, it will start to wiggle that way, lift will redirect it, and until it starts to go down, lift is keeping it straight it's not like the balloon, because the balloon doesn't have fins, so the balloon just kind of goes like, but the rocket does have fins, which uses lift to make it go straight. So a cool thing about lift is it only works with the wind. So when the rocket's just sitting still like this, there's no lift. If I knock it over, it's going to fall over. There's no lift because there's no air going around it. So that's why the rocket needs the really long rod on the launch pad, so it stays straight until lift kicks in and takes over so it can go straight up. So real rockets in space don't have to worry about lift and drag since they're in space and there's not really any air in space, so it kind of doesn't have to worry about that all. So once your rocket is in space, then all you have to worry about is gravity and thrust. So you don't have to worry about any of the other stuff because that's caused by the wind, not caused by anything else. And you might have thought that there's no gravity in space. That is totally untrue, but we'll cover that in a different video. But full-scale rockets can redirect the force out of the engine and steer themselves. And that is called one of my new favorite words, gimbal!
Okay.
I can just say it forever. Gimbal, 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 gimbal. Next, we are going to be talking about with our rocket is weathercocking. And what weathercocking is we've already talked about drag. So drag is the wind going down against the rocket. But the wind might also be blowing this way. So you add those two vectors together, and that's the direction the rocket is going to act like the wind is going. And since we talked about lift, it's going to turn slightly into the wind, and you're going to do those calculations over and over and over again, which is what makes the rocket fly in a parabola. This is just a really quick summary of the 4 forces that act on a rocket. I highly recommend you check out NASA's website. There's a link in the description. It explains full on the forces that act on a rocket. So if you'd like to know a lot more about building model rockets and how they're going to fly, then definitely check out the website, which there's a link in the description below. As well as, if you've never built a model rocket, do it. Although, be prepared, you might lose rockets, because we built a really cool rocket, but it went way too high, so it flew into some random person's yard, and we don't know where it is. So, thank you for watching, and I'll see you tomorrow. Bye!